I'm now moving on to the optimization and modeling homework problems. And for question number 1, I have a farmer who has 120 meters of fencing available, and this farmer wants to make 2 rectangular pens. So here are my 2 rectangular pens. There's one in yellow and one in green. And basically I have 120 meters to go around here, 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 and on this vertical length right there. Okay, and basically this question is asking what are the dimensions that will give the maximum area. Okay, so whenever you're doing a optimization problem, I recommend, just like in class, that we should label the diagram. Now we're very lucky for this question because the diagram is given to us and all we need to do is label the diagram, usually with the variables x and y. So this distance right here, that red distance, let's label that x. And this distance right here, let's label that x. And this distance right here, let's label that x as well. Okay, so I have 3 x's there for the horizontal distance, and I have one more vertical distance right here, and I'll label that y. Okay, now for this particular problem, we don't care about the wall side because the wall is being used as one side of the pen, so we don't need to use the 120 meters to cover that part of the problem. So I can just erase this left-hand side right there. Okay, so that's step number 1, you just label the diagram. And for step number 2, you want to find a derivative equation. All right, so we need to find a derivative equation. Usually the derivative equation can be found in the last sentence. So if I take a look at the last sentence here, what dimensions will give the maximum area? So if I'm looking for a maximum area, if you want to maximize or minimize anything, you need to take the derivative. So this will work with the derivative equation. All right, so how do I find area? Well, look at the diagram right here. The diagram is simply a rectangle, and ask yourself, what is the area of a rectangle? Well, the area of a rectangle is length times width, so area equals to length times width. Now, what is the length? Well, the length is just x, so I'll be x, and what is the width? Well, the width will be y. So x times y is your derivative expression. Okay, now from there you want to take the derivative like a prime, but the problem is there's a y variable here, right? There's 2 different variables there, x and y, and you can't take the derivative in these kind of problems if there's 2 variables, so you have to get rid of this y variable. The way you get rid of the y variable is in your 3rd step, you need to create a helper equation. Okay, so here's my helper equation, and in order to find your helper equation, you have to read the problem, and usually the helper equation goes with the number that's given to you. Now, if I read this problem very carefully, let me just erase all this. There's only one number that's given to me, and that's 120 meters. So in order to create my helper equation, I need to look at my x and y variables and that 120 meters and put that together. So I need to connect the 120 meters with the 2 variables that are given to me, which are x and y. All right, well, how many x's do I have? I have 1, 2, 3. I have 3 x's plus this 1 y. And the 3 x's plus the 1 y, that equals to 120 meters, right? So that 120 meters covers all 3 of those x's and that y. Okay, and if I isolate for y here, y would equal to 120 minus 3x. Okay, so now you can see that this y right here is the same thing as that y right there, and now we can do a substitution step. So area would equal to x times 120 minus 3x. Okay, let me just erase all that. All right, so now this is my my new derivative equation, and notice that I have one variable now, which is x, and now I can go ahead and take the derivative. But before I take the derivative, let me go ahead and simplify this one more time here. So x times 120 is 120x, and then x times 3x, well, that's going to be negative 3x squared. And after that, then we can take the derivative. So a prime would equal to 120 minus 6x. Now, if I want to maximize or minimize anything, I need to take the derivative and set equal to 0. So 0 would equal to 120 minus 6x. And then we just solve for x here. So bring the negative 6x over. So that would be 6x equals to 120. And then divide both sides by 6. If I do that, x would now equal to 20 here. So 20 meters. And if I go back to my helper equation, this is my helper equation right here. So now that I've found x to be 20, I can plug that over in there. And now y would equal to 120 minus 3 times 20. So that's going to be 120 minus 60. and y would now equal to 60. All right, so the dimensions that will maximize the area are 60 meters by 20 meters. All right, so if I go back to my diagram here, I think this was the wall, and I believe it was set up like this. So this would be 20, that would be 20, that would be 20, and this distance right here would be 60. And the area right now, if I take the length right here, which is 20, and if I times that by 60, 60 times 20 is 1,200 meters squared. So this is my final area, and the dimensions that will give me the area of 1,200 meters squared would be 20 by 60 meters. Okay, let's move on to the second problem, the homework. For question number 2, given two numbers have a difference of 10, determine which pair of numbers gives the smallest product. Okay, so this question is slightly different because we don't have a diagram like the previous problem, but we would still follow the same steps for all these optimization problems. First, we want to label the diagram, or how about we just label the problem, I guess. There's no diagram here. So we're given two numbers, so we can let x be the, let's say this is the first number, and then y can be the second number. All right, so that's labeling the problem. And for step number 2, I need to find the derivative equation. All right, in order to find the derivative equation, we can usually find that in the very last part of the sentence here. So determine which pair of numbers gives the smallest product, right? So smallest product. Product means multiply. So I need to find an equation for product, and I need to incorporate my two variables that were given to me in part 1. So since my two variables are x and y, if I want to find product, I'll label that p. Product would be x times y. Okay, so if I want to find the smallest product, that's like minimizing this question. I need to find the derivative here, but once again, there's two variables x and y. So let's try to figure out how to get rid of the y here. And in order to do that, I need to write up a third statement, which is the helper equation. Now for the helper equation, I need to look at the numbers that are given to me in this problem. And if you look at the problem very carefully here, there's only one number that's given to me, and that's 10. So two numbers have a difference of 10. So how can I use x, y, and 10 to make an equation? Well, since it says difference, the difference of x and y would be x minus y, and that would equal to 10. And once I do that, let's go ahead and isolate for y here. If I isolate for y, I'll just bring y to the other side here, and then it will be x minus 10. So y would equal to x minus 10. And as you can see, these y's right here, they're connected now, and now I can write a new derivative equation as x times x minus 10. All right, so now we can take the derivative of p. But before I take the derivative of p, let's go ahead and just simplify this. X times x would be x squared, and x times 10 is negative 10x. And now that I have one variable here, I can now find the derivative. So in order to find the derivative of p, the derivative of p is p prime, and that would be 2x minus 10. And if I want to minimize anything or maximize anything, the derivative needs to be set equal to 0. And then this would be 2x minus 10. And then let's go ahead and solve for x here. So it'll be 2x equals to 10 over there. And then divide both sides by 2. And this one's not too bad. X would now equal to 5. Okay, now that I found 5, I can just take this number right here, 5, and plug it back into my helper equation. So this would be 5 minus 10 equals to y. So my second number is going to be negative 5. So negative 5 equals to y. So my two numbers are positive 5 and negative 5. Those are the two numbers that would satisfy this problem. Okay, let's move on to the next question in the homework section here. All right, now I need to find two positive numbers that have a sum of 18. Okay, so two positive numbers have a sum of 18, and determine the pair of numbers if the product of one number and the square of another is a maximum. Okay, so another weird word problem. So let's start off by labeling the problem. So let's label the problem. Now, because we're given two positive numbers, let's just say x is the first number. And let's just say y is the second number. Okay, so that's how you label the problem. And then for our next step, let's go ahead and set up our derivative equation here. Okay, so here's my derivative equation. Now, once again, for the derivative equation, you usually want to look at the very last part of the sentence here. So it says we want to find the product of one number and the square of another number is a maximum. Okay, so let me just erase all this because what we really need to focus on is this part right here. The product of one number and the square of another number is a maximum. Okay, so if I'm looking for a product, I can start off by saying P equals the product of one number, so one number could be x, and the square of the other number, so the other number is going to be y, so it would be y squared, and that product is going to be a maximum. Okay, so we do need to read the last part of that question very carefully so that we can come up with our derivative equation here. Now, this is the equation where we want to take the derivative of, but notice that we have two variables, so we want to get rid of one of the variables so that we can take its derivative. In order to get rid of the second variable here, we need to set up the helper equation. And for the helper equation, we need to look at the entire problem and find where the number is given to us. The only number that's given to us is 18. And how is the number 18 affiliated in the problem? Well, it says two numbers have a positive sum of 18. Alright, so I need to figure out an equation with the two variables x and y and 18. And since it says sum, we can just add x plus y equals to 18. Okay, now for our next step is I need to take a look at my two variables in my derivative equation. I have an x here and I have a y squared there. In the two previous problems, we were isolating for y because the problem just ended up like that. But sometimes you have to be very careful and look at the problem and ask yourself what would create the least amount of work. And if you actually substitute for x, this will create the least amount of work because then you don't need to deal with the y squared there, which means you would have to FOIL and collect like terms. So I recommend that you get rid of the x here. So in your helper equation, let's look at the x here. How can I isolate for x? Well, x would equal to 18 minus y. Okay, so this x and that x are the same thing now. So my new product equation will be product equals to 18 minus y times y squared. And you'll notice that the next step is actually going to work out very, very nicely here. Let me just erase all that. Because if I take this y squared here, I can easily distribute that into the brackets, which creates less work. So this would be 18 y squared minus y cubed equals to p. Notice that I can easily take the derivative on my next step without doing a lot of algebra work. So in this particular problem, it's actually better to substitute for x and not y. All right, let's go ahead and find the derivative now. P prime would equal to 36y minus 3y squared. And for this particular problem, if I want to maximize anything, I need to take the derivative and set it equal to 0. So 0 equals to 36y minus 3y squared. And then I would go ahead and take this negative y squared term, bring it to the other side. And that would equal to 36y. And then I can divide both sides by 3. And those 3's would cancel. Y squared would equal to 12y. And then the y's here can cancel. So now y would equal to 12. So one number in this particular problem is going to be 12. Okay, so how do I find the other number? Well, since we know that y is equal to 12, I can go back to my helper equation now. So back to my helper equation. I know that y here is now 12. So in order to find x, it would be 18 minus 12, and 18 minus 12 is 6. So my two numbers are x equals to 6, and x and y equals to 12. So those are the two numbers that satisfy this particular problem. Okay, so that's it for part 1.